Terrible black holes. While many of these unusual astronomical formations are regularly identified and thoroughly studied, other outgrowths of the cosmos have always presented grand galactic mysteries, particularly the fabled white holes. The various objects and structures in the vast expanses of the universe, such as rapidly rotating pulsars and enormous nebulae, are both fascinating and bizarre. The mystery surrounding these fascinating objects primarily stems from the fact that experts have not yet been able to demonstrate their existence, which explains why the speculative formations are still significant in the field of astronomy, and the astounding theory some researchers have recently proposed regarding the actual impact of white holes. We'll show you in today's video if you want to accompany us on our exploration of the universe's greatest mysteries. To ensure you don't miss any of our future movies, please click the bell and subscribe to Simply Space. You can also give us a thumbs up if you enjoy the content of our postings. White holes. As is often known, black holes are celestial objects with intrinsic masses that are concentrated into minuscule volumes. This natural, incomparable compactness generates such a strong gravitation in their immediate areas that no form of information, not even light, can cross the event horizon of a black hole from the inside to the outside. In other words, this means that anything that comes within the sphere of influence of one of these gravity monsters is irretrievably swallowed up. You might say that white holes are the exact cosmic opposite of black holes. Consequently, this means that the hypothetical objects incessantly eject mass, making it impossible to pass their event horizon from the outside to the inside. For this to be accomplished, a velocity higher than the speed of light would be required. Thereby, the theoretical existence of white holes results from possible mathematical solutions for the equations of the general relativity theory. However, the circumstance does not necessarily mean that white holes actually exist. As already mentioned at the beginning, researchers have so far failed to provide clear evidence for the existence of these entities, while white holes and black holes differ from each other in terms of their gravitational characteristics. They have one fundamental thing in common: the so-called singularity in the center in the world of astronomy. Singularity refers to places where gravity is so strong that the curvature of space-time diverges there, or in simple terms, it's infinite. When it comes to the properties of white holes and their formation mechanisms, different theories exist. One assumption is that they are in fact black holes which run in the opposite direction to the time axis. Not less exciting is the thesis that white and black holes can form wormholes together. Matter, which is swallowed by a black hole, would be ejected again from a white hole through a galactic exit in a completely different part of the universe, both spatially and temporarily. What's more, some experts consider it conceivable that the very birth of the universe could be regarded as a white hole was the Big Bang. A white hole, according to our current knowledge, the Big Bang occurred about 13.8 billion years ago. Contrary to the first assumption, this process was not a gigantic explosion where components of the cosmos were hurled into an already existing space. Rather, it means the common emergence of space-time and matter from an original singularity, and indeed some scientists suppose that just that birth of our galactic home is to be traced back to the effects of a white hole, among other things that support this idea. There is the fact that the models agree with the laws of the cosmological principle. These laws say that the universe is built homogeneously and isotropically, presenting itself the same to the observer independently of his point of view and observation direction. In other words, we cannot exclude that the universe itself is a very large white hole. However, we cannot confirm this thesis with certainty. Either, if it's true, it would still take many billions of years before the edge of this cosmic sphere would come into view. White holes could help to increase our knowledge considerably, not only with respect to the Big Bang, but also with respect to another great astronomical puzzle. Specifically, the exact composition of ominous dark matter, a postulated form of matter that helps explain the motion of visible matter in the standard model of cosmology. If we take a closer look at galaxies, we see that stars orbit the visible center of their cosmic home much faster than would be expected from the gravitational pull of the celestial bodies. And the dust and gas clouds, researchers estimate that only 5% of the matter in the universe is visible, despite the fact that dark matter plays a significant role in its spectacles. The proportion of dark matter is set at 23%, while dark energy, an equally hypothetical form of energy that can be used to explain the universe's accelerated expansion, accounts for 72%. Given the background that visible matter is concentrated inward, some Spanish experts recently proposed a new theory that suggests the mysterious dark matter may be composed of microscopic white holes. According to Kepler's third law and gravitational law, the orbital velocities of stars should decrease the farther they are from the center of their ancestral galaxy. However, reality demonstrates that the corresponding orbital velocities of the glaringly bright celestial bodies remain the same, or even increase with increasing distance from the galaxy core. This unexpected situation leads to the urgent conclusion that some form of mass exists that is responsible for these effects, specifically dark matter. The aforementioned study by the Spanish researchers finally comes to the conclusion that tiny white holes could account for a significant amount of dark matter. As things get a little more theoretical, experts calculated that one microscopic white hole is required for every 2,400 cubic miles in order to transfer the derived density of dark matter to the field of white holes. The local density of dark matter, which is derived from the motion of stars near our Sun, amounts to about 1% of the Sun's mass per cubic parsec. The astronomical length measure parsec corresponds to roughly 20 trillion miles. According to the scientists, if a proton were to strike one of these tiny structures, it would simply bounce off it due to the characteristic properties of white holes. The collision between a black hole and one of these small white holes would result in an even more massive black hole. However, the revolutionary explanations of the experts do not end there. As previously mentioned, some researchers believe that the Big Bang itself could be considered a white hole, or at least as a consequence of its existence. The new theories now say that some white holes could have formed even before the Big Bang. This is because the corresponding structures would be much smaller than a proton and weigh only a millionth of a gram. Future research should, therefore, help to explain why time in the universe only moves forward and not backward. Have we found a white hole? If experts are successful in establishing the existence of white holes beyond a reasonable doubt, it would be a major astronomical milestone. However, while most researchers currently concur that this proof has not yet been presented, some believe that we have already seen the effects of a white hole. 15 years ago, NASA's Swift satellite recorded an exceptionally powerful gamma-ray burst in 2006 that did not correlate with any known occurrences of this type. The burst lasted for an astounding 102 seconds, whereas the typical time span is at most 30 seconds. What's even more perplexing is that the emission could not be linked to a stellar explosion, because it occurred in a galaxy with virtually no stars capable of producing such powerful emissions. Several years later, some scientists hypothesized that a white hole could have been the source of the gamma-ray emission. The reason for this is that the event in question had the characteristics that we would typically expect from a white hole, a huge, unstable emission of energy and matter that disappears again shortly after its occurrence, although it cannot be officially ruled out that it was indeed a white hole that caused the much-publicized 2006 outburst. Researchers' models to date have not been able to provide a conclusive explanation, and this despite the fact that the event has been eyed by many space telescopes. Since its discovery, ultimately scientists can say only one thing with last certainty. They were confronted at that time with a phenomenon which they had never seen before. We're interested in your opinion. What do you think about the fascinating white holes and the fundamental role they play in the universe? We're already looking forward to your comments. Want to see more exciting videos about the groundbreaking discoveries and unique spectacles in space? Then click now on one of the images in the credits to get to the other contributions on our channel. Thanks for your interest. Take care, and we'll see you next time.